Okay, so next piece of story problems that we're going to look at actually ties into the piece of story problems that we were talking about with finding that when it hits the ground piece. Now we just need to take it a little bit further here. So now we want to sort of look at every piece of a quadratic. Maybe. I don't know where I set that right now. That's good. So let's say we're looking at a quadratic. I don't know, pretend this is perfect. Right, this is our time happening down here way back when, way, algebra 1-1. Right, we talked about our x-axis. Right, if we didn't know what it represented, it was always time. That was what we should have guessed. Okay, that's the same situation we're going to be looking at today. Just like the story problems we were looking at the most of the time, this is going to be our height, our distance, something like that. Okay, we've already agreed that over here at this point, we're talking about solving it, and we're talking about using the quadratic formula. Right, that's the piece we've already looked at that we say we should be okay with. We're okay there. What is this up here? What's this point? Okay, it's the highest point. What's the vocab word we use for that?
Oh, like the story.
Okay,
Sorry.
it is. I mean, it is that, but what's the math term we use for it?
Height.
Oh. No. Wait, what's it start with? The rise.
A V.
Vertex.
This is our vertex.
I knew it.
Okay, and how did we say that we would find a vertex if we were given a quadratic trinomial? What did we say we would do, Donovan? Isaac, what do you say? Okay, so H and K is if it's given to us in vertex form. Okay, that wouldn't be already written in its quadratic trinomial form. That was our standard form. How do we find the vertex if it was in standard form? Right, negative b over 2a. So this is an x value. Our x-axis is time. Okay, so this value right here would be telling us when it's at its max height. How do we find its corresponding y value? What did we have to do to find the y value? Right, we had to plug x back into the equation. Okay, our y value is our height. So this would be telling us our max height. Can we agree with those three things? Okay, so I'm going to pass out some more story problems here. Okay, so first of all, check, make sure I didn't do what I did last time. Make sure yours says notes at the top. You should notice that what we're looking at here looks almost exactly the same as what we just looked at with finding when it would hit the ground. The difference is that now we're going to be able to find more pieces. Okay, it still has very little to do with all the words that are happening within the story problem. And it has everything to do with understanding how we find a vertex and what that vertex represents. So number one says, suppose a football player kicks a ball and gives it an initial upward velocity of 48 feet per second. The starting height of the football is 4 feet. We represent this width. Right, so all those first sentences are a little bit irrelevant. We just need to know that that's talking about that equation there. If no one catches the ball, when will it hit the ground? What do we do to decide when the ball will hit the ground? Quadratic formula. Okay, so for part A, we're doing the quadratic formula. Okay, so A is -16, B is 48, C is 4, right? We'll start plugging in. So -48 plus or minus 48 squared. Right, and kind of at this point, you should be like, okay, it's a little bit tedious, but I know exactly what I'm doing because I'm plugging into the quadratic formula. And it should be just like those sets of problems we talked about with finding when it hits the ground. So we'll calculate underneath the square root. Let's see, -48 plus or minus 2560. Okay, we'll take the square root of the 2,560. Right? Doesn't matter if it's a perfect square or not because we're ready for a label. So we're either going to have to decimal approximate it or we'll get a perfect square. In this case, we have to approximate. Okay, so we'll have -48 plus or minus 50.6 by the time we round, right? Because we get 0.596. That 6 tells us to bump up the 9, which then tells us to bump up the 5. All over -32. And then we'll calculate both options. So let's see, -48 minus 50.6. Which one of these answers are we going to want to pick?
Positive.
The positive, and what label are we going to give it? Seconds, because it's when it will hit the ball or hit the ground. Okay, so for part A, we get 3.08 seconds. Part B, when will the ball reach its maximum height? So same equation, same story problem, but now we want to know when the ball will reach its maximum height. So what did we say we would do to decide when the ball reaches its maximum height? What are we going to do? What does this say? Negative b over 2a. Negative b over 2a is going to tell us when the ball will reach its maximum height. Okay, so for part B, if we want to decide when it will reach its maximum height, we're going to calculate negative b over 2a because the vertex is the maximum. Right? And to calculate the when part, the time part is the x value. And the rule says x equals negative b over 2a. So let's see, negative b, negative 48, over 2 times negative 16. We get 1.5. What label goes on that 1.5? Seconds, right? Because this is a when again. When will the ball reach its maximum height? At 1.5 seconds. Now, let me ask you this. Does it make sense that this has an answer of 1.5? Well, what is the vertex? So if I look here at the vertex, where is this located in relationship to my two solutions or my two x-intercepts? Exactly in the middle. right? That's the definition of the vertex. It's the maximum right in the middle. It falls on the axis of symmetry. So it's not going to be perfect because we had to do some rounding here. But is 1.5 basically in the middle of those two numbers? Yep, sure is. Okay, so that's a reasonable solution. Okay, part C says, how high does the ball go? So what's the maximum height of the ball? Well, what are we going to do to calculate the maximum height of the ball? Plug it back into the original equation. What are we going to plug back into the original equation? The negative b over 2a, because we find our y value by using our x value. So we're going to plug this 1.5 back into our original equation. So we'll say negative 16, and then in parentheses 1.5 squared plus 48 times 1.5. So again, just comes back to the calculator. Oops. How high did the ball go? 40, what label does it get? Feet, 40 feet. There's our answer for part C. Questions on that one? So far, so good? Our next one. I guess I should say, oh no. The equations used to represent a child throwing a ball is, okay, and it gives us an equation here, right? Equations, plural, because we have some letters that we would need to fill in, so that's representing all of them. Where h represents the height of the ball, v is the initial upward velocity, t is time, and c represents the starting height. Ugh, this time it didn't nice and neatly give us that equation, did it?